Hi guys, let's continue with where we left off in the last video. So in the last video we started talking about partial fractions and having a look at an example of how to do partial fractions and having a look at some of the complex cases that we can see when we start doing partial fractions. So let's have a look at a couple more complex cases that we could see when solving partial fraction decomposition integrals, okay? So let's say we've been given to find the integral of 2 over x cubed plus x squared dx. You can see that this has repeated linear factors. So this is going to be our first case where we're going to see repeated linear factors in the denominator. Okay, so let's have a look at how we're going to solve this. So again, as we were doing as we were doing in the last video also, we want to get them into separate partial fractions, right? So if you see, we are separating these two, x squared times x plus 1, right? So I'm trying to factor it out. What this is going to do is this is going to help us find our partial fractions. Okay, now the question that comes in is, are we going to do a over x or a over x squared, right? Which one of these are we going to do? What we're going to do is we're going to do a over x. Okay, we're going to do a over x. So the rule that we have is that there must be a partial fraction for each x over x, for each exponent of x. Okay, in this case, since we have double, right? So what this is going to look like is going to look like b over x squared, sorry. So a over x plus b over x squared plus c over whatever our third fraction, which is just going to be the x plus 1. Okay, now let's just solve it like how we were doing for the previous problems also. So multiplying this both sides, we're going to get 2 on the left side, a over and now we're going to multiply. What we're going to do is we're going to multiply a times x, and we're going to multiply because this needs an x, right? Just to fulfill that, and it needs an x plus 1. Okay, and here it doesn't need an x, it just needs x plus 1. I kind of think it like that, b x plus 1. And the third, c, it needs an x squared. Okay, now let's set them to their individual. Let's try finding these individual values of a, b, and c. So I'm thinking let's set it to 0 first. Okay, so setting it to 0, what that would do is, let's set it to 0. Since one of our x values is just x in, we can just plug in 0. So 2 equals, so this is going to be 0, right? This is going to be 0 because the x squared, 0 squared is just 0. What we're going to left with is this 0 plus 1, 1, and that is going to give our b value. Okay, now I'm thinking, let's set our x value, since we have x plus 1, let's set it to negative 1, since that would cancel it out. So 2 equals, this would make it 0, this would make it 0, but this would make it negative 1 squared is 1, so this is going to be our c value. Okay, now coming for our last a value, let's set for a, what we would need to do is let's set how about we set it to 1, right? Let's set x equals to 1. Since we don't really have a number that could cancel both b and c out, let's set it to 1 and see how we could solve it. So 2 equals, right? So we're gonna get 1 plus 1, 2a plus now, since we all know what b and c are, right? We could use those values. Plus 2, x plus 1, 1 plus 1 is just gonna be 2, plus we know what our c value is, 2, right? And our x is gonna be 1 squared. Okay, so 2 subtract the 4 both sides and 2 both sides, and we're gonna get 2a. So 2 minus 4, negative 2, negative 2, negative 4. So negative 4, right? Negative 4 equals 2a. And divide both sides by 2, we're going to get a equals negative 2. Okay, guys, so this is something we didn't see before. This how we just plugged in b and c. So do take a note of how we plugged in b and c to find, instead of canceling both b and c out. Okay, so now next step, since we've gotten our values, hooray, what we could do is plug them in. Okay, let's plug in the integral. So what is it? What is our a value? A is negative 2, so we're going to find the integral of negative 2 over x plus b 2 over x squared plus c plus 2 over x plus 1. Okay, so this, we can find the individual, of course, dx. We can find the individual integral, but this, as we've been looking at, it's going to be negative ln over x. Okay, but here, this one we will, I'll write it down as, since it has factor of more than 1, right? So I'm going to write this down as 2 times x to negative 2, right? Because we can't just do ln of and put x squared over there. Okay, but for the third one, since we could just put that in our natural log, right? Because since that doesn't have right, that doesn't have the x squared, the power of 2 that this has. Okay, so now what that next step would look like is negative 2 ln of x plus, so we take the 2 outside, and we're just going to do the normal power rule for integration. Okay, so this is going to be x to the negative first, right? Subtract 1, right, and bring it down 1, right? And then what this is going to turn into, negative 2 x to the negative first plus 2 natural log of x plus 1. Okay, guys, and that is our answer. You could also write this down as negative 2 over x. That you could also write it down like that, but plus c. Do not forget that plus c. Okay, so that is our answer, guys. Negative 2 ln of x minus 2 over x plus 2 ln of x plus 1 plus c. Now, what if we get repeated factors? What are we going to do if we get repeated factors? Okay, let's have a look at a case where we're going to have repeated factors, more than, not just x squared, right? Where, as we saw in this question, it's not just x squared. What if we have x to the third, right? Now, just to have a look at a change in letters, let's do an integral, a definite integral, right? Instead of an indefinite integral of 2 over t cubed times t plus 1 dt. Okay, dt. But this would be, again, how this would look like. The definite integral for this would look like, again, you might be wondering what would our first partial fraction be. What it would be is a over t. Remember, we want a partial fraction for each of the individual factors of t cubed. Okay, so a over t plus b over t squared plus c over t cubed plus d over t plus 1. Okay, d over t plus 1. And now, next step would be to multiply these by t cubed over t plus 1, t cubed, t plus 1. Okay, what we're going to be left with is 2 equals a. Okay, a, since that one t is going to cancel out one of those t, so we're going to a t squared t plus 1, and we're going to be going on b. It's going to be bt t plus 1 plus c t plus 1 plus d. That just needs a t cubed. Okay, and we can set them to their individual values. T equals 0, 2 is going to be equal to, so this is going to be 0, this is going to be 0, this is going to be 1. So 2 is going to equal to C. And that's going to be 0. So 2 equals, C equals to 2. Okay? Let's set T equals to -1. Okay? 2 is going to be equal to -1 squared. That's going to make it 0. That's going to make the whole thing 0. That's going to make the whole thing 0. That's going to make the whole thing 0. This is going to make it -D. Okay? So our D value is negative. D equals -2. What else? Let's set T equals to 1. Okay? So 2 equals A times, that's going to make it 1. 1 plus 1 is 2. Okay? 2B, right? 2B plus 2C plus D. Okay? Plus D. Now, again, this is one of those steps that we have to, what do we have to do? We have to plug in the previous values. So A 2 times let's do one thing. 2 times A plus 2 times B, right? But okay, so 2 times C. 2 times C is gonna give us 4, and D is gonna give us -2. So we're gonna get, let's just plug in C and D and see 2A plus 2B. Okay, so and what this plus 2, right? So that's gonna make the left hand side 0. Okay, it's gonna make it 0. Next step is, let's set T equals to 2. So 2 is gonna be equal to A times whatever our T was. So T is gonna be 4 3 plus B 2 3 plus C and then 3 plus 2 to the 4, 4 to the 8, 8, right? D times 8. Okay. Since we don't already have our A and B, that's why we just left it as A and B, right? Since we don't already have that, we only have C and D. Okay, so 2 equals to 12A plus 6B plus C. We found it as we found C value as 2, right? So 2 times 3 is going to give us 6, and -2 times 8 is going to give us negative 16. Okay, so 12, if we do the subtraction, it's going to be 12 equals to 12A plus 6B, 2 equals 2A plus B. Now if you solve the system of equations for both this and this, right, both of these equations, you're going to get A is going to be equal to 2, B is going to be equal to -2. Okay, after finding A is going to be equal to 2, A equals to 2. So after finding that, we're going to get the integral of A over what is, so what did we find A? We found A 2 over, what was it? T, right? T plus, what is B? -2. -2 over T squared plus C. What is C? C is going to be 2 over T cubed plus D. What is D? D is -2. -2 over, what was it again? T plus 1. Okay, again, solving the integral for each of these, it's what the final answer would look like, just to, since we've been doing the similar integrals of this and this, what it's going to look like is, for ln of 2 minus 2 ln of 3 minus 1/4. Okay, that's what it's gonna look like. And and we've also got to mention the plus C. We also got to do the plus C. Okay, So that's what our final answer looks like, guys. Thank you so much.